Hey everybody, we're here at Geo Week 2026 in Denver. I'm here with Eatay Ben Shechter. Hey Eatay.
Hi Jeffrey.
Good to see you again. So, tell us about Skyline. What is Skyline? What do you do?
Skyline is a software solutions company. We are very 3D focused. We develop anything that has to do with image processing, taking data, images, LiDAR, producing 3D geospatial products such as textured meshes, Gaussian splats, orthos, point clouds, and we also have the ability to visualize, analyze, measure, and disseminate using the internet with our Skyline Globe server. So a full end-to-end data to product 3D solution.
And I guess you have one of the leading solutions for really large-scale 3D reconstruction, right? You have huge projects with aerial data or terrestrial data, and you're able to process literally, hundreds of thousands of images into a single coherent model.
Correct. We have a very scalable architecture that utilizes parallel processing. So multiple computers can participate in the same task or work on the same project. And then it's just a matter of resources. You can run a project on 5 computers or you can run it on 500. So we can scale to really large amounts of data and large amounts of area. So project size and amount of pixels.
So what's new with you guys over the last, 6 months to 1 year? What's new?
New is, a lot of focus on the Gaussian splat, improving the Gaussian splat quality, accuracy, performance, and adding additional applications on top of it, measurement, analytics, additional AI object detections and things like that, to take advantage of the amazing visual quality that it has. So I think that's going to be a lot of focus on the industry for utility applications, for different type of construction, where it really lends itself to thin features, really small, fine level of detail.
Okay, so with Gaussian splats, it's a lot more viable to view certain types of objects in real 3D that was not so easy using textured mesh. Correct,
yes. A mesh has to have geometry in order to see the texture. So you need a triangle, and the triangle needs to be textured. With a Gaussian splat, the ability to visualize essentially the original data in 3D, the original pixels, creates a much more appealing visual view that is similar to what the image looks like, the original image looks like, as opposed to an interpolated pin with texture. So poles and fences, things like that, they look very realistic.
So what types of customers want this from you and which ones don't? Where do you see the demand for 3D Gaussian splatting?
Good question. So anything that has to do with aesthetic quality is really gaining a lot of attention. Meshes traditionally didn't really pass the aesthetic quality test. For engineering purposes, they are amazing, they're accurate, they're precise. You can measure volume, you could measure really anything you want, you could overlay GIS on them. But they never passed the visual quality test. So things like gaming, commercials, marketing applications, real estate, things where the visual quality is critical. The other one is utilities, which are traditional LiDAR or point cloud customers are looking into cost cutting, utilizing images only, and what sort of benefits they can get from the additional details they see in the Gaussian splat if they don't necessarily need the LiDAR.
Okay. Do you have more and more customers who are going this image-only route rather than images and LiDAR or LiDAR only?
Yes. A little bit. It's starting. It's a minor trend. Essentially, with the Gaussian splat, the level of detail is dictated by the resolution. So if you're going to collect 5 centimeter image, that'll be your Gaussian detail. But at 1 centimeter, the amount of details you can see of the Gaussian splat in terms of power lines, leaves, individual leaves on a tree, it just becomes very detailed. And at that point, trying to compete with that level of detail with LiDAR density becomes extremely prohibitive. If you have 1 centimeter data, it's 100 by 100 pixels, 10,000 points, 10,000 pixels on a square meter. and getting LiDAR to represent that level of detail is almost impossible.
How many points per square meter is LiDAR usually, or what range is it?
It could get in the, if it's dense, it's in the hundreds.
Okay.
To get over 1,000, close range, really terrestrial scanning type of stuff. But
right.
it's not scalable
Right.
to large areas.
Okay.
Entire corridors scanned by hand.
So the cost of additional computation, you can get something much more dense using images, where with LiDAR, it might be a little bit less computation, but it's,
The resolution. It's what you could see is the resolution.
Yeah.
So if a screw is 2 centimeters radius and you have 1 centimeter data, you're going to see it. With the LiDAR, in order to represent that, you need a lot of points over that very small area.
Okay. One kind of reservation I've heard about 3D Gaussian splats is they're not metric. It's hard to make measurements.
That's the improvements.
So you guys have solved this?
I mean, the measure, we can measure on the splat. We already have the ability to measure area, distance, overlay, volume measurements. So we already have that. I think where the improvement is going to come is in the precision of the splats that are being produced, so that the measurement is more accurate off of them. And that was essentially true of a mesh. Think if a mesh does an interpolation and it doesn't pick up a little bump in the road and smooths it out and flattens it.
Right.
When you go and measure that, that's going to be wrong on the mesh.
Yeah.
So the accuracy of the measurement is as accurate as the fidelity of the product. High fidelity mesh will produce high fidelity measurements. High fidelity Gaussian splat can also produce high accuracy.
Right.
So that's where, but it's in a starting phase. Meshes have been developed for over 10 years now. And this is maybe in its first year and a half. So, but it's getting there. It's moving fast.
Do you think, it's been moving fast, this whole field of NERF, 3D Gaussian splats. There was a couple years where it was moving so quickly.
Now this one seems to be sticking a little.
So it's here to stay, you think? It's viable?
Well, I can't predict the future, but at least for a couple of years.
Yeah, yeah. You haven't heard anything yet that's around the corner?
I hear all the time, but it's all a derivative of this. Triangle splats, it's similar, but everybody's trying to squeeze a little bit more juice out.
Okay.
I haven't seen anything that is as big of a paradigm shift as this. At least not in the near future, but who knows? Things move fast.
So this 3D Gaussian, this elongated blob, it is as important as a pixel in 3D now. It's this atomic unit is something that will be used into the future as
I hope so. Yeah, I mean it's starting to get incorporated into standards, commercial standards, and once that gets done, a lot of platforms can integrate it.
Okay.
And then they can build their own tools on top.
Okay. So there are sufficient open standards around this that the data can be shared and
it's starting
collaborated upon?
Yeah, starting.
Okay. Well, I think that's all the questions I have for you, Itai. Thanks a lot for coming by. It's great to see you again.
You too. Always a pleasure to work with you guys.
Great. Thank you.